Earth magnetism theory. Earth is a giant magnet, has a north and south pole. The Earth's magnetic north pole is at the Earth's south pole, and the Earth's magnetic south pole is at the Earth's north pole. The inaccuracy of the Earth's magnetic north and south poles is called declination. The Earth's magnetic field also forms an angle with the Earth's horizontal, which is called the angle of inclination. The Earth's magnetic field serves to protect the Earth's inhabitants from cosmic radiation, electrical particles produced by the Sun or other celestial bodies that are harmful to health. With the Earth's magnetic field, electric particles cannot enter the Earth's surface but only enter the Earth's poles. When they hit Earth's atmosphere, electric particles or ionized OR electrons are released from the nucleons and form a weak plasma OR supergas is heated to eject electrons from the nucleons. This beautiful display of plasma light is called the aurora. Here's what the aurora borealis looks like. Lorentz style. A current-carrying wire in a magnetic field will experience the Lorentz force. The electric current is proportional to the force generated, as E is the change in the applied magnetic field. As a result of the direction of the current I and the direction of the magnetic field B perpendicular to each other, mathematically the Lorentz force is written as follows. F equals B times I times L. F equals B times I times L. Description: F equals Lorentz force, Newton. B equals fixed magnetic field, Tesla. I equals strong electric current, amperes. L equals length of the current carrying wire entering the magnetic field, meters. Determination of the direction of the Lorentz force can be done using the right-hand rule. Like the following picture, the application of the Lorentz force is an example of an electric motor. An electric motor is used to convert electrical energy into motion energy. An example of an electric motor in everyday life is the electric motor on a fan that functions to move the propellers. Electromagnetic induction. Electromagnetic induction is a change in a magnetic field that can produce electricity. According to Faraday, electric current can be generated by moving a bar magnet in and out of the coil. Applied to generators, AC or DC dynamos and transformers. Generator is a device used to convert motion, kinetic energy into electricity. The energy of motion is obtained from the energy of wind, water, and so on. There are two generators, namely AC, alternating current, and DC, direct current generators. An AC generator or alternator can produce alternating electric current using a double ring. A DC generator can produce direct current using a commutator, split ring. Here's an example. A C generator. B. DC generator. Dynamos are relatively small generators like those used in bicycles. On a bicycle there is a dynamo which converts motion into electrical energy to turn on the lights. The way a dynamo and generator work is almost the same. The difference is that the dynamo has two main components, namely the rotor, the moving part, and the stator, the stationary part. The following is an example of an AC-DC dynamo. When the bicycle is pedaled quickly, the coil on the dynamo moves quickly so that the induced electromotive force, EMF, is stronger and produces more electrical energy. Induction EMF is obtained by accelerating the rotation of the coil. Using a strong magnet, increasing the number of turns, and using a soft iron core in the dynamo. A transformer is a device that is used to lower or increase the voltage based on its use. There are two types, namely a step-down transformer to lower the voltage and a step-up transformer to increase the voltage. Here's an illustration. The transformer consists of primary and secondary windings connected using an iron core. The primary winding that gets AC voltage induces the iron core to become a magnet. Changes in the direction of the AC current make the magnetic field formed varies, resulting in an AC voltage at the ends of the secondary coil. The size of the voltage generated by the transformer is influenced by the number of turns. If the primary winding is more than the secondary winding, the secondary coil voltage is also less than the secondary coil voltage. The transformer is called a step-down transformer. If the number of primary windings is less than the secondary winding, then the secondary coil voltage is greater than the primary coil voltage. The transformer is called a step-up transformer. In an ideal transformer, the electrical energy that enters the primary coil will be transferred entirely into the secondary coil. This results in the transformer efficiency being 100%, or mathematically written as following. Description: WP equals primary energy, W equals secondary energy, IP equals primary current, is equals secondary current, NP equals primary winding, N equals secondary winding, VP equals primary voltage, versus equals secondary voltage. In fact, a transformer with an efficiency of 100% ideal has never been made, because some of the electrical energy that enters the primary coil will be converted into heat. One of the reasons for this change in electrical energy into heat is the presence of eddy currents in the iron core. Calculation of the transformer is not ideal done using the following formula. Description: POUT equals secondary coil electric power. PIN equals primary coil electric power. Magnetism in technology products. Magnetism is widely used in technologies such as magnetic resonance imaging, MRI, maglev trains and nuclear power plants, NPP. MRI is a tool to detect disease, using the principle of magnetism to image the health condition of bones or internal organs of humans without going through surgery. The person who will be checked for health is put into a magnetic field which has a strength 5,000 times stronger than the Earth's magnetic field. The magnetic field causes the body's nucleons to rotate and line up parallel to the needle of the compass figure. Then the nucleon is bombarded with radio waves to induce its direction, figure B. When the direction is parallel, figure C, the nucleons emit radio waves which are eventually received by the computer as an image of the condition of the internal organs of the body, figure D. The image can show the presence of disease in the human body, figure E. This technique is safer than X-rays. Here's the picture. In addition to detecting the presence or absence of diseases such as tumors, MRI can be used to record the human mind. For example, to record the part of the brain that responds to hot or cold stimuli, and can be used for early detection of epilepsy symptoms. Maglev trains, magnetically levitated or flying trains, are trains that are flown plus or minus 10 millimeters above the tracks. Even if the rails and trains don't stick together, the super-fast maglev train can go up to 650 kilometers per hour. It won't fall and slip. This is due to applying the principle of magnetic repulsion and is driven by an induction motor. Maglev trains have become a means of mass transportation in developed countries such as Japan, America, China, France, Germany, and London. In Japan, trains that use this principle, for example the Shinkansen train that connects the cities of Tokyo, Nagoya, and Osaka. Here is a picture of the Shinkansen train, nuclear power plant. PLTN is a power plant that uses nuclear energy. The way it works is like conventional power plants, for example coal power plants. Water is heated using coal fuel until it evaporates. The steam produced is used to drive a turbine, which in turn drives a generator. This method can reduce the amount of non-renewable natural resources and can pollute the environment due to combustion that produces carbon, sulfur and nitrogen fumes. In nuclear power plants, heat is obtained from the nuclear reaction fission in a nuclear reactor. The heat generated reaches 1.5 million degrees Celsius, so that no material on Earth can withstand the heat. So that the heat does not spread to the environment, a magnetic bottle with a very large magnetic field is used. Here is a picture of a nuclear reactor.